Okay, we're going to talk about piecewise functions. Piecewise functions are made up of two or more functions. And these functions each have their own domain. So each with their own domain. So we're going to be looking at several functions. All of these functions will have their own domain. This is an example. We have 3 different functions, and all 3 of them have a different domain, and we're going to graph these. All right, so let's look at this first example. This first example, it wants us to evaluate when x is -5. So x is -5 is with which domain? Where does -5 fit in these domains? So -5 is less than -3. So that means we're going to look at this equation. You guys see that? Okay. Because -5 doesn't fit between these two. And -5 is not greater than 7. So the only one it works with is this top one. So that's the function we're going to use. So I'm going to write down this function, 2 absolute value, but I'm going to plug in a -5. And then we'll evaluate it. Okay, so guys, -5 minus 5, -10. And what is the absolute value of -10? It's just 10. And 2 times 10 is 20. So the answer here is big 2O. All right, let's look at B. Which function should we use for B since we want x value 2? The second one? Yep, this fits right here. 2 is between -3 and 7. So we're going to use this equation. So I'm just going to write it down. In my parentheses, I'm going to put in a 2. All right, what is 2 squared? 4, but it has to be a negative because there's a negative in the front. Plus 8. What is this? That's my answer. Perfect. Okay. Now, this one wants the x value 7. Will I use this one or this one? Why am I using this last one?
It's more than or equal to.
Yes, because it's equal to. Here we cannot equal the 7. Okay, you can put in 6.999, but you can't put in 7 because it's not equal to 7. We can use this one though because this includes 7. So I'm going to write down this function and I'll put in a 7. And what do we get here? 2 times 7 is 14, plus 6 is 20. And guys, you're going to have to reach back into your memory. How do we break this down? Yep, the square roots of other numbers. What are 2 numbers that multiply to 20?
4 and 5.
So we can do the square root of 4 times the square root of 5. And what's the square root of 4?
2.
So this is just 2 square root of 5. This is called simplifying your radicals. Okay. All right, so that's an example of evaluating some piecewise functions. Let's practice graphing them, okay? Let's practice graphing. I want to do a harder one with you. I think this one's pretty easy. I want to do a challenging one with you. So I'm going to do I'll do number 4 with you guys. Let's do number 4. At the very bottom of the next page. Okay, so let's look at these different functions. The very first one, it says f of x equals 7. Let me highlight what I'm talking about. F of x equals 7 if x is less than -1. So let's go ahead and graph this. This is basically the equation y equals 7. So I'm going to go up to 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. That's this line. we only want values that are less than -1, when x is less than -1. So here's -1. I'm gonna cut off my line here. So my line is always only gonna come up to -1. I'm not gonna continue it all the way this way. I'm only gonna draw my line up until -1. Guys, why did I do an open circle at the -1? Exactly, there's no equal to sign. Okay, so that is my first function. Let's go ahead and graph the second one. So, what happened? There we go. Okay, so let's go ahead and graph the next one. This is an absolute value equation. Let me highlight it for you. We are going to do f of x equals this absolute value function if x is between -1 and 2. Okay, so guys, what's the transformation here? What happened? It went to the right one? Okay, so let's draw that. Our absolute value function went to the right one. So this should be your new graph. I'm just going to draw it. However, guys, we're not going to draw the whole thing because it's restricted. It only wants this graph from -1 to 2. So here's -1 and here's 2. So I'm going to erase anything outside of that. So let's draw this again. I only want this graph between -1 and 2. So I'm not going to draw the whole V, just part of the V, between -1 and 2. Is that okay? Okay, another thing, guys, you can always plug in numbers. Okay, let me show you how to do that, what I mean. Guys, look, the first number in your domain is a -1. So if you plug in a -1 right here, what's -1 minus 1? -2. And what's the absolute value of -2? 2. So that means we plugged in a -1. So at -1, you should be right here at 2. You can just keep doing that. Plug in a 2, plug in a 2. You'll get 1. So you can also just plug in your points to get this graph. Okay? All right, let's move on to the third function. So the last one. Let's plug in a 2, guys, and let's see what this graph looks like. So I'm going to plug in a 2 right here. What is 2 times 2? What's the square root of 4? And what's -2 plus 1? -1. Okay, so we plugged in a 2 and we got out a -1, right? So we're going to plug in a 2 and we got -1. So I'm down here. Open circle or closed circle? Open, because that's just the greater than symbol. Okay, let's continue graphing. Let's plug in a 3 next. Let's plug in a 3. So this time, guys, I'm going to plug in a 3. So let's plug in a 3 for the x value. Oh, actually, what's a better number to plug in?
An 8.
4.5? That's good. What's 2 times 4.5? 9. 2 times 4.5 is 9. Everything else will come down. And what's the square root of 9? Perfect. So we get -3 plus 1, which is -2. So when we plugged in 4.5, we got -2. So here is 1, 2, 3, 4. 4.5 is between 4 and 5. -2, we're right here. So it looks like our graph is going this way. Let's plug in one more number and then we can be done. What number should we plug in next? 8? Good choice. Let's plug in an 8. Let's plug in an 8 and see what we get. What's 2 times 8? 16, what's the square root of 16? 4, bring everything down. -4 plus 1 is -3. So when we plug in an 8, 1, 2, 3, 4, 5, 6, 7, 8, we're at -3, right there. So your graph goes like this. So that's your piecewise function. Okay, so let's go ahead and talk about the domain and the range. Okay, so my domain, guys, let's go ahead and start on the left. On the very left, what is it pointing towards? Yes, so my first thing is -infinity. Okay, it continues this way. Let me get my highlighter. Okay, my graph continues this way. Oh, and it jumps right here at -1. So is -1 included? It's open here, but it's closed right here. So -1 is included. It's good. So even though the graph jumps, the domain is still good. And it continues. Right here, something happens. Is 2 included? Yes, because there's a closed circle here. So 2 is good. Even though there's a hole here, it's okay. It's closed right here. And then we're going to continue after 2 to what? Infinity. So it's all real numbers, exactly. It's -infinity to infinity. Even though there's lots of breaks in my picture, because there's closed circles at those holes, it's included. So our domain is all real numbers. Okay, now let's try the range. Where do I start for the range? The bottom. You always start at the bottom for the range. Okay, so the bottom of my graph, let me highlight it for you. Here's the very bottom. What is it pointing at? -infinity. So my range starts at -infinity. And let's follow. Let's follow. It goes up, and there's a break right here. Where is that? That's at -1. Is it included? No, it's an open circle. Okay, we're continuing to move up. So where is the next part? Right here at 0. 0 to what? 2. Guys, we're talking about the height for range, how tall it is. So it goes from 0 to 2. So I'm going to put a union symbol. It goes from 0 to 2. Are these included? Do I need parentheses, brackets? Yes, brackets. There's no holes. So these need to be brackets. Okay, and then what? What's the next part? It's right here at 7. Does it go anywhere below 7 or above 7, or is it just 7? It's just 7. It's just 7. So I'm just going to put 7. Because we can, yeah, you don't really have to put the bracket. You could just put 7. I just put the bracket. So that means your y values go from -infinity to -1, from 0 to 2, and then 7. Let me erase this table so you don't get confused. All right, so that is our range. Okay, guys, last question. It asks, where is the graph decreasing? Where is the graph decreasing? Well, look, let me highlight it for you. It's decreasing from here to here, isn't it? Right here. What's the interval where it's decreasing? We're talking about the x-axis. It's decreasing from where to where? Yes, it's decreasing from -1 to +1. Right, because it starts increasing after 1. Okay. And then when does it start decreasing again? Yep, from 2 to -infinity. But how do we write that, guys? I'm sorry, 2 to +infinity, right? Because it's going to the right. Okay, it's going to the right, so 2 to infinity. Increasing and decreasing intervals. Okay, are we good on the piecewise? I'm gonna have you guys practice graphing piecewise equations. Okay, just check your work. Most of you guys finished this one. So guys, this is an absolute value function. Tell me the transformations. Exactly, left 3, down 1. So if I were to graph this, I'm gonna go left 3, down 1, which is right here. That means that's my vertex and this is my graph, right? However, it only wants this graph for the x values less than 0. So that means, let me edit this. I can only go up to 0 for this side. And I can't include 0 because there's no equal sign on the 0. So that's what this graph should look like. Now let's do the other function. This is 2x minus 5. So that's just a linear function. It's just going to be a straight line, a diagonal line. I'm going to start at -5. 1, 2, 3, 4, 5. That's my point. And my slope is 2. So go up 2 over 2. I mean, up 2 over 1. Up 2 over 1. So this is the line for that one. It's going to look like this. Okay. And I'm including this point right here because it has an equal sign for 0. Okay, so we can include 0. So this is what your graph should look like. Let's talk about the domain. The domain has negative infinity on the left. It goes all the way to here, but guys, there's a closed circle right there. So it is okay. And then it continues off to infinity. So this is all real numbers. All the numbers work. All the x values are represented in this graph. Okay, now let's talk about the range. Here's the very bottom at -5. It will be a bracket at -5 because this is included. And it goes up to infinity. So it goes up to infinity. This part does not matter. This break does not matter because there are y values on this line. It's included. It goes from -5 and it goes forever up. So guys, were there any discontinuities? Did you have to pick up your pencil to trace this graph?
Yes.
Yes, there's a discontinuity. Where is the discontinuity? At what x value is there a discontinuity? 0. So guys, let me show you. Let me clean this up a little bit. Okay, right here, your graph broke right here. It went from here to down here. So that's your discontinuity. And the location of that discontinuity is at x equals 0. Okay, let's pretend there was a graph right here and it went like this. Where's your other discontinuity? One, two, three, four, 5. There's a discontinuity right here at x equals 5. That's what you mean by discontinuities. Make sense? Where you have to pick up your pencil to draw again. That's where your discontinuity is. Okay, let me erase that example.